Today, we're diving into three crucial areas: app interactions, hardware compatibility, and connectivity testing. These elements ensure that our technology not only works smoothly, but also plays well across devices and networks. Let's explore how they come together to create seamless user experiences in the real world. Today, we're diving into hardware compatibility testing, making sure apps play nicely with device software, even when interruptions happen. We'll explore how different connectivity methods and varying bandwidth affect performance. Then, we'll look at screen orientation and how apps handle multitasking. Finally, we'll walk through practical test scenarios and real-world examples to bring it all together. This agenda sets the stage for a thorough look at ensuring apps work smoothly across devices. Now, let's talk about testing against device sensors and physical constraints. This means making sure our app works smoothly with things like accelerometers and gyroscopes, which handle screen tilting, step counting, and gaming controls. We also test GPS and location services to ensure accurate mapping, manage battery use, and detect fake locations. Biometrics are crucial too. Fingerprint scanners and face recognition need fallback options. Finally, hardware compatibility testing ensures everything runs well across different devices. This step is key to a seamless user experience. Hardware compatibility testing is all about making sure our devices and components work smoothly together. We put hardware through its paces, checking for any glitches or conflicts that could cause problems down the line. This step is crucial. It helps us avoid surprises, reduce downtime, and deliver a seamless experience. By testing compatibility early and often, we build confidence that everything will perform as expected when it really counts. When we test hardware compatibility, it's important to remember hardware features aren't always available or active. Imagine a user revokes camera access right in the middle of a scan, or the GPS signal drops while they're navigating. Our apps need to handle these situations smoothly. A well-designed app doesn't just assume hardware will always be there. It adapts, recovers, and keeps working without frustrating the user. That's the kind of resilience we're aiming for. When we test hardware compatibility, we focus on how the app behaves under specific conditions. For example, at low battery levels or in battery saver mode, the app should pause background syncing smoothly, no crashes allowed. If the camera or microphone is busy with another app, users need a clear, straightforward error message. Low storage or RAM. The app must protect data and warn users before downloads fail. And for foldable devices, the UI should adapt instantly when the screen unfolds, without losing any input. These checkpoints keep the experience solid across devices. Let's talk about interruption testing, how apps handle real-world disruptions. When you're using an app, things happen. Calls come in, notifications pop up, or the device switches between apps. Interruption testing checks how well an app responds to these moments. It's about making sure the app doesn't crash, lose data, or behave unpredictably when the device software interrupts its flow. This kind of testing keeps the user experience smooth, no matter what's happening around the app. When we talk about interruption testing, we're focusing on a crucial moment, when the app gets paused because something else demands the user's attention. A good app handles this flawlessly. It saves its state without a hitch, so when the user comes back, everything is exactly as they left it. Imagine filling out a long form, then getting a call and returning to find all your work gone. That's a nightmare. This is where many apps stumble, and where interruption testing proves its worth. Now, let's take a closer look at the interruption test matrix. This tool helps us understand how different interruptions affect our workflow and focus. By mapping out various scenarios, we can identify where disruptions hit hardest and where we have room to adapt. It's a practical way to see the impact of interruptions, so we can design better strategies to manage them and keep our momentum going. Now, let's take a closer look at the interruption test matrix. This tool helps us understand how different interruptions affect our processes or systems. By mapping out these scenarios, we can predict where things might break down and where they hold strong. It's a way to prepare, so we're not caught off guard when real disruptions happen. This matrix is a key part of building resilience into our work. When we talk about navigating network instability, one key strategy is embracing network diversity. That means using different types of connections to stay online. Cellular networks come in many flavors, from 2G all the way up to 5G, each with its own strengths. Then there's local wireless options like Wi-Fi, which itself splits into 2.4 and 5 GHz bands, plus Bluetooth and NFC for close-range links. To keep things smooth, regular connectivity testing helps us spot issues before they become problems. Let's talk about bandwidth switching and transitions. What happens when we move from Wi-Fi to cellular, like leaving home while streaming a video? We also face challenges passing through dead zones, elevators, basements, tunnels where signals drop. On the edge network side, high latency means data gets through, but responses can take over 10 seconds. Packet loss causes partial transfers, corrupting data or freezing requests. That's why connectivity testing is crucial to keep things running smoothly.
We can't rely only on fast, stable campus Wi-Fi when we test. Real users face all kinds of network challenges. Walking into elevators, driving through tunnels, or connecting to weak public Wi-Fi. If we want our product to perform well everywhere, our testing has to reflect that. That means using network throttling tools to simulate slower speeds and interruptions. Testing under ideal conditions isn't enough. We need to prepare for the real world.
Let's talk about testing network resilience, a crucial step to make sure our app performs well no matter the connection. We start with a full signal to confirm everything runs smoothly under ideal conditions. Then, we simulate poor signal, like 1 bar or high packet loss, to see if the app handles timeouts gracefully. Next, we test no signal or offline mode, checking offline caching and error messages. Finally, toggling airplane mode mid-transaction helps us catch any edge cases. Network throttling and offline testing together build a robust user experience.
Let's talk about network throttling and offline testing. Two crucial tools for building reliable experiences. Network throttling lets us simulate slower connections, so we can see how our app performs when bandwidth is limited. Offline testing goes a step further, helping us understand how things work without any connection at all. Together, these methods ensure our projects stay smooth and functional, no matter where or how they're used.
Let's talk about adaptive user interfaces and how they handle state preservation. When you rotate your device from portrait to landscape, the system actually destroys and recreates the screen. On Android, this means the activity or view is torn down and built back up. That can cause issues if your app isn't prepared. So, orientation and display testing become crucial, making sure your interface adapts smoothly, and users don't lose their place or data when switching views. It's a key part of creating a seamless experience. When we rotate a device, a few key problems often pop up. First, data loss. This happens when input fields get wiped clean as the screen turns 90 degrees. Then, there's UI overlaps. Buttons or text can shift off-screen or scrollable areas get cut off, making interaction tricky. And media playback reset. Videos jump back to the very start instead of continuing smoothly. That's why thorough orientation and display testing is essential to catch these issues early. Let's talk about multi-window and split-screen features. These let us resize app boundaries dynamically, so two applications can share the screen smoothly. It's a powerful way to boost productivity and multitasking. But to get it right, we need thorough orientation and display testing, making sure everything looks and works perfectly, no matter how the screen is divided or rotated. This ensures a seamless experience across devices and use cases. Rotation testing goes beyond making sure the layout looks good when you turn your device sideways. In Android development, rotating the screen actually restarts the entire life cycle of the screen view. That means if the developer hasn't saved the state properly, any user input, like text or selections, will vanish immediately. So, rotation testing is crucial to catch these issues and ensure a smooth user experience, no matter how the device is held. Now, let's dive into a practical case study focused on mobile banking money transfers. We'll explore a real-world scenario that highlights key challenges and solutions. Alongside, We'll review a sample test suite designed to ensure reliability and security throughout the transfer process. This example will help us connect theory with practice, showing how testing frameworks support smooth, trustworthy financial transactions on mobile devices. A brief transitional moment here as we move between sections of the presentation. Let's continue forward to the next topic, which we'll explore in more depth. When we design for hardware interactions, it's crucial to test how our app behaves when sensors like GPS, camera, or biometrics are missing or turned off. We need to handle interruptions, like phone calls or battery alerts, as normal system events, making sure the app saves its state every time. Connectivity can be unpredictable, so we simulate weak signals, delays, or even no connection at all. And finally, changing screen orientation or switching apps should never cause users to lose their data. These are the key takeaways to keep our apps reliable and user-friendly. As we wrap up, think about the risks when an app stores full credit card details locally. What could go wrong? Also, consider how testing on a slow 2G connection differs from offline testing. Next time, we'll dive into common mobile test types and explore experience-based techniques. Now, let's open the floor for questions and discussion. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.